All right, welcome everyone. This is our first of three-part series over the month of September. I'd like to welcome you all to Nashville Public Television's Educator series. My name is Rosemary Brunton. I am the Community Engagement Manager and Educator at NPT, and I'm thrilled that you all are joining us over the next couple of weeks as we dive in some amazing resources developed around the Ken Burns film, The Gene and Intimate History. We will be looking at PBS Learning Media collection over the next few weeks. And I do want to pause and say that all of these professional presentations will be recorded and available after the series is over so that other educators in our area can have access to this information. So as a part of a grant from WETA, who is the producing PBS station for the Gene and Intimate History, this organization has developed curricula and other resources for use by middle and high school teachers. Among the available resources that we'll be going over in the next few weeks are lessons, modules, and including video clips and Common Core connections, next generation science standards, as well as the national standards that you'll see in all the content that we have to share. During this series, we'll also have information to share on how to discuss challenging and ethical conversations with students. And our hope is that providing interdisciplinary materials to support holistic learning that will promote critical thinking by your students. Our goals are to prepare teachers to teach the gene in their classrooms by providing comprehensive background materials and resources, and provide educators with classroom activities that combine both powerful medium of film and traditional standard-based curriculum, as well as to raise the awareness about the Gene film series and educational materials among teachers in Middle Tennessee. I'd also like to welcome and who is aiding me in this endeavor at the station. I'm joined by the Personal Genetics Education Project team, Robin Bowman and Nadine Vincenten, who will be not only walking us through this incredible content that's available for free, but what's more is we also invite you to join us between each of these sessions on the Slack workspace platform. You can share your discoveries there, ask questions throughout the week, and today Robin and Nadine will be going over on how to use Slack, along with introducing you to all of these fascinating resources for educators. And before I go, if you have any questions, please feel free to raise your hand or post a comment in the Q&A. And Robin, Nadine, the time is yours.
Thank you, Rosemary. I appreciate the introduction there. I'm going to go ahead and share the results of our poll. Let's see what everyone likes for their superpowers. It looks like teleportation and invisibility were tied this time around. All summer long, I think teleportation has been the top winner in our polls, and our theory is that it's because everyone has felt pretty cooped up because of the whole COVID situation that people would love to just be able to like snap and be somewhere else. But invisibility is making a strong showing today too. Very good. All right. I don't think we're anywhere near being able to edit our genes for superpowers, but who knows? Maybe someday we'll be able to choose a superpower for ourselves. All right. I am going to start off by sharing my screen here, if we can get that to go. All right, is everyone seeing the presentation now?
Yeah, showing up for me.
Okay, awesome. So as Rosemary said, Nadine and I are from Personal Genetics Education Project. We're based out of the Department of Genetics at Harvard Medical School. And basically what our job is all about is just getting more people involved in the conversation around personal genetics and the ways that genetics may come into all of our lives. Some people may think like, oh, I'm not interested in genetics, or I don't understand genetics. But we're firm believers that these conversations can't just be happening at Harvard Med School or can't just be happening in biology classes and that sort of thing, because there's so many ways in which genetics comes into all of our lives, and there's some big decisions that we have to make regarding them. So we like to go out and have these conversations with people, and a big part of what we do is actually working with educators, because we know in the classroom is where, teachers are tackling a lot of these issues, and they're preparing students, to be the independent healthcare consumers, the voters, the parents of tomorrow, the, business leaders, the, healthcare providers, and everything. So we really find our work with educators to be really key to what we do. So today we're going to talk about bringing personal genetics into your classroom with The Gene, an Intimate History, and PBS Learning Media. I don't know if any of you have had the chance to read The Gene, an Intimate History, but it's a very thick book that rested on my nightstand for several months, by Siddhartha Mukherjee, that sort of gives a really comprehensive history of the gene and the ways in which kind of the social history of genetics as well. And it has been turned into a PBS film, and we had the great pleasure this past year of working with WETA, the PBS station out of Washington, DC, on creating educational resources to partner with that film. It just felt like a really natural kind of coalescing of what we did, because so much of what we normally talk about was also covered in the film. And so it was a really great opportunity we had. All right. So as I said, Personal Genetics Education Project, our whole goal is to increase awareness, to stimulate thoughtful discussions, to help people make informed choices, and to create engaged communities. I think sometimes there's a misconception to think that, our group, because we come from the Department of Genetics at Harvard Med School, that we would just be completely pro-genetics, all genetic technology and that sort of thing. But that's really not our mission at all. Our mission is to try to provide information on all sides of issues related to genetics, and to get people talking about it, and more people involved in the conversation. A big part of what we do is create free resources, especially tailored for teachers. A big part of what we do is create lesson plans. The lesson plans that are available will have like a slideshow, a lesson plan document that gives you a whole lot of background information, as well as lists the standards alignment, gives you slide notes, and will include like activities, homework, or quizzes to give to your students. Our lesson plan documents can be pretty thick, but our goal with them is to give you all of the information that you would need as an educator to just take one of the presentations and present it, and not have to do a lot of other kind of background research on your own. In addition to the lesson plans that we've offered for years, this spring and summer, we spent a lot of the time and effort working on creating distance learning resources. We know that because of the COVID-19 pandemic, it's kind of challenged educators to go about things in new ways, because so many people have had to switch to doing online education. And so we thought, since we work with teachers so much, one of the best things we could do is to help them more easily make that transition by providing some distance learning resources. So what we've done is taken some of our lesson plans and kind of chopped them into smaller pieces, and created what we're calling snapshots. And each one of these snapshots is meant to be like a 15 to 20 minute student-facing lesson that really doesn't require any presentation from a teacher at all. And they're just, again, freely available on our website. You can easily, put the link to them, in your learning management system or whatever, and your students would be able to do them independently. As well as, we have recorded versions of our presentations available there as well. Again, a lot of teachers this summer, we were doing professional development events, and that's the reason that we recorded our presentations. Previously, we never had them recorded. And after our PD workshops, we had several of the teachers ask if they could just use the recorded presentations with their students instead of having to go through presenting the lesson on their own. So we thought, why not? And went ahead and posted the recorded presentations as well. So those are available to you. As I said, this year we had the great privilege of being asked to participate in creating these learning resources that are paired with the film The Gene and Intimate History that is available through PBS. It was a super exciting project for us to work on. Currently on the PBS Learning Media website, they still have the full film available for streaming. It has been up quite a bit longer than they normally leave the full films up. When it came out this summer and teachers saw that it was there were a lot of teachers who were actually assigning it for their students to, watch the full film or whatever. And after the normal amount of time came that they leave the film up, they actually took it down. But they got a lot of requests from teachers saying, could you please, make this available again, because I really wanted to use it with my students. And so they have very graciously been willing to put the full film back up on the website to stream. I do not know currently how much longer it's going to be up, but I can tell you as of today, it is still there. So if you want to see the full film, you can. It is divided into 2 episodes. Each one is about 2 hours long. So the full thing is a 4-hour film, but it is a very engaging 4 hours, I can say. I have watched it several times in the past year, so it's good every time, and I learn more each time. All right. So the reason that we're talking today is because the field of genetics is changing so quickly, right? And as technology advances, the cost of the technology comes down. And with that lower cost means that we have increased access to those technologies. More people have access to them, and more people are using them. Oh man, I have trouble with this. These new advances in genetics are becoming really personal. And we're more able to learn about our DNA now than we ever have been able to previously. But learning about our DNA has some consequences, right? Learning about our DNA can offer insights about our health, our behavior, our family history, and other traits. Some of those things are really important when you're learning things about your health and health conditions that you may have or may be able to pass on to your biological children. Other things are just more entertaining. You can learn about traits that you probably already know. Like you get genetic tests done, it'll tell you whether you're likely to have curly hair or attached or detached earlobes, or what color eyes you have and that sort of thing, or whether or not you like cilantro. It can be interesting, but trivial there. Learning about your DNA can give you information that has personal, social, and familial impact. One of the examples that we give here is that, you can have DNA testing done to find out your risk for developing a disease. For example, early onset Alzheimer's disease. And maybe you're curious to know that, but maybe others in your family aren't curious to know that. And when you learn something about your DNA, you're also learning about the people that you share DNA with. So, if you're going to have genetic testing done to find whether or not you have an increased likelihood of developing early onset Alzheimer's, your parents may not want to know that information. So you might want to find out from them in advance before you start talking to them about your results, right? Learning about our DNA can lead to improved healthcare. Oftentimes, it's genetics is where you find the key to figuring out the answer to different health conditions or problems that they may not have been able to figure out any other way. It can lead to complicated questions about how to use genetics personally and as a society. Not everyone agrees on how these new technologies should be used, or even if they should be used at all. And when we develop new technologies, we also have to figure out how they're going to be regulated within our society. Our lawmakers have to decide which technologies are legal, how they're going to be regulated. Are they only available through healthcare providers? Are there certain things that are going to just be available, over the counter? And so we really need to get a lot of people kind of talking about that. And there are also challenges about how to ensure fairness and equity in genetic advances. You know, these new technologies are expensive to develop. Like, genetic research costs a lot of money. And a lot of times when new technologies come online, they may be still considered experimental. You may not have insurance companies covering some of the new treatments that come out. And even if insurance companies do cover the treatments, not everyone has health insurance. And so that can bring really big questions about, you know, how can we make it so that people have equitable access to this advanced technology, and don't set it up as just another example of a place where those who have great financial means have access to the benefits of it when others do not. So when we talk about the ways in which personal genetics is affecting people, we kind of break it down into three kind of overarching themes. One is medicine and health, and then ancestry and identity, and then the third one is society. We'll talk a little bit about each one of these and give you a brief overview. All of these things will be covered more in depth in the next week with work you'll do independently with our introduction of personal genetics lesson, so I don't want to cover it too in depth. But under personalized medicine, when we think about genetic testing, again, it can solve medical mysteries. It can reveal disease risk, so it might let you know something about how likely you are to develop a disease in the future, when right now you may not be showing any symptoms or have any reason to believe that you might be at risk for something. You could find out ahead of time and then know to, like, keep an eye on that, go in for screenings, do whatever lifestyle changes you can to prevent the disease, that sort of thing. It can predict a person's response to a medication. I know this was a really interesting thing. When I originally learned it, I had always assumed that, you know, a medication is a medication. It's a chemical compound and it's going to have a certain effect on a body, and that effect is going to be the same from one body to the next. But it turns out that's not true. And depending on, you know, different versions of genes that you have can really affect how your body metabolizes different medications and whether or not certain ones will work for you at all. Genetic testing can inform our medical decisions, also inform reproductive decisions. A lot of times the first time that genetics like really comes into people's lives in a really personal way is when they're deciding or trying to have children. And it may be that, you know, a couple is having difficulty conceiving, or it could be that a person already is pregnant and the doctor is asking whether or not they want to have some genetic tests done. And so people have to make some big decisions about that. And genetics is a place where you can get a lot of information very early on. And genetics can be used to create personalized treatments. Like I said earlier with the medications, how not all medications are going to work the same for everyone. Now that we can get so much information about our genes, we can actually tailor treatments to work specifically for individuals. We have a lot of resources that are available to you about personalized medicine, and that's a lot of what we're here to do today, is just kind of point you to where you can find all of these resources. Each of the things that you see here are resources that are available through the PBS Learning Media website. So related to personalized medicine, we have an introduction to genetics and medicine. There's one on genome editing and CRISPR, which we'll talk about more next week. There's one, when new treatments come with big hopes and a big price tag, which talks about kind of a groundbreaking treatment for spinal muscular atrophy, but it's currently the most expensive medical treatment available. Identifying and understanding rare genetic conditions. That one's about Meet Test Bigelow. So that talks about a family's journey to discovering the genetic condition that their child has and how that goes forward. And it shows kind of a parallel story with the Yoder family in the film, who in their family, they're dealing with spinal muscular atrophy. And then the resources that are there about Test Bigelow is just another condition as well. And then history, access to care, and emerging genetic-based therapies. Talks about sort of the history and some equity issues that are out there. Besides the things that are available on the PBS Learning Media site, there are also other resources that are available through the pgEd website at pgEd.org. So the three that you see across the top there are all full lesson plans about personalized medicine, about reproduction, and then again about genome editing and CRISPR. And then the ones that you see on the bottom are smaller, those snapshot lessons that are meant to be about 15 to 20 minutes long. All right, kind of the second broad category of personal genetics that you're talking about is genetics and ancestry. With these direct-to-consumer tests that are on the market now, a lot of people are learning about their genetics because they're curious about their ancestry. Rosemary, I don't know if you're able to launch that poll to ask about whether or not people on the call today have done the genetic ancestry testing. I'm not sure if that's going to work or not. There we go. Yeah, so just a quick poll to see of the people that are here today, how many of you have done one of those genetic ancestry tests? All right, looks like nearly everyone has. There we go. We can show the results here. So this group, not a whole lot. A lot of times we're talking to groups and up to half of the people, or sometimes even a little more than half, we'll see have done it. This particular group, it looks like only one of you has done the ancestry testing. Get rid of that. Oh, all right. So, ancestry testing is something that can be done very simply these days. You buy a kit, whether you order it online or you just go to your local department store or pharmacy, you pick one up off the shelf. You collect a spit sample in a tube and you mail it off to the company and they analyze it and they send you back results. This ancestry testing, it can answer questions that you have about your family lineage. It can reveal thrilling and or painful histories. Some people are excited to learn information about their ancestry, but other people get information returned that is maybe surprising or doesn't line up with, the family stories that have been told, and may open some old wounds, could be painful. So it's something that you really need to think about before you go into the ancestry testing, about whether or not you're able to accept whatever results may come. It can connect people to their past. For some people, they have family stories that go back generations and they feel a good, a really strong connection to their ancestors. But for other people, depending on whether, it's because of adoption or donor-assisted conception, or just immigration, or even, the history of the slave trade, for many reasons, people may not have that strong connection to their past. It may have been lost somewhere along the way. And so through ancestry testing, you can, reclaim some of that and kind of connect to, the areas of the world where your ancestors came from. And it can affect a person's sense of personal identity. There's, thousands of stories out there about a person who, my family had always said that, our ancestors immigrated from, this certain area of the world. And it turns out, it seems like, my ancestry results say that, it's likely that we came from somewhere else. So some of those results can kind of change your personal identity. Again, there are several different resources that are available to teachers through PBS Learning Media. There is Ancestry and Identity in the Genomic Age, one on direct-to-consumer testing, and then how does ancestry testing work? And this one is really fascinating. Nadine actually created a little animated video that explains how it is that these ancestry testing companies come up with those results that they send you. How do they give you those percentages and how accurate are they, or how sure can they be that your ancestors come from a certain area of the globe and that sort of thing. And it's kind of fascinating. I know I learned a lot during the process of working with Nadine as she created this resource, and it's pretty fascinating to see. And again, some more resources that are available to you. We have full lessons on how does ancestry testing work and on consumer genetics, and then a couple of snapshots as well. All right, and then kind of the third overarching theme is just about genetics and society. I think oftentimes when we think of genetics, the first thing that comes to mind is probably either healthcare or ancestry. But there are other issues that just kind of affect society in general. And this is one of the reasons why we think it's really important to foster these discussions, because genetics are used in law enforcement, right? They take DNA sample, they find DNA samples at a crime scene, and then they compare it against people who are in their database. Genetic testing can be used to convict criminals who are guilty of crimes. They can also be used to exonerate people who have been, wrongfully convicted and incarcerated. But there are also issues of equity just based on who is in the law enforcement databases. It creates issues with, certain populations are more likely to have their DNA or the DNA of someone they're related to show up in those law enforcement databases. So a lot of societal conversations need to happen around that. There's privacy rights related to your DNA. Your genetic information is the most personal information that you could possibly imagine, right? This is like the recipe book for you. And so, you need to think about that in terms of what are you doing with that information, who has access to that information, how do you want it shared? And, on a broader societal level, we have to talk about what are the laws going to be in terms of privacy rights surrounding genetic information. There has been legislation passed called the Genetic Information Non-Discrimination Act, or GINA, which basically says that your genetic information cannot be used to discriminate against you in employment. So your employers cannot ask you for your genetic information. They cannot make hiring, firing, promotion decisions based on genetic information. And also GINA protects you when it comes to health insurance. Health insurance companies are not allowed to make determinations of whether or not to offer you coverage or about how much they're going to charge you for that coverage based on genetic information. So, GINA is great legislation, offers some really important protections, but it does fall short when it comes to life insurance or long-term care, long-term disability insurance. It does not provide protections against discrimination when purchasing those sorts of insurance policies. So those companies are able to ask you if you know about your risk for developing genetic diseases and that sort of thing, and they may deny you coverage, or they may charge you more for coverage based on the information that you give them. Okay. Recently, Florida was actually the first state to pass its own legislation that sort of extends GINA coverage to life and long-term disability insurance. And, I'm guessing that other states will follow suit if we don't have an extension of those rights at the federal level. Other societal implications, eugenics. I know, a lot of people, when you hear the word eugenics, the first thing that comes to mind is probably Nazi Germany. That's the place that we hear of most commonly with the eugenics movement. But I know it was news to me when I started working at pgEd that the United States actually had its own eugenics program that was in place well before Germany had its program in place. And there's a long history of eugenics practices that went on, and it wasn't some sort of fringe thing. It was supported by a lot of prominent scientists, a lot of prominent leaders of community and business and politicians and that sort of thing. And there are ripples of that movement that continue on today. It didn't look exactly like it did in Nazi Germany, but our country basically encouraged certain people that they should produce more children because they were considered to have positive traits, and it would be good to pass their traits on to offspring. And then other people were deemed to be inferior in some way or defective, and they were either discouraged from having children or prevented by the government from having children through forced sterilizations. Right, and so we have a full lesson on the American eugenics movement. It's also covered in the Gene and Intimate History, and it's very eye-opening and very sad. Other social implications of medical research. When we talk about medical research, there are issues of equity and inclusion when it comes to who is being included in this medical research. Are all populations involved in it? And if they're not, then is this research applicable to people from all populations? And how do we make sure that everyone is included and able to benefit from the research that is done? Issues of access and equity, we talked about already. And then also environmental applications. So when we're talking about genetics, it doesn't just necessarily mean human genetics, but we may be talking about, the genes in the crops that we grow to eat, or it could be the genes in mosquitoes. We're now able to genetically modify mosquitoes so that they're not able to pass on some mosquito-borne illnesses like Zika virus or dengue fever or malaria. But again, there are conversations. Not everyone agrees with whether or not it's a good idea to release genetically modified mosquitoes. On the other hand, some people say they pass on these diseases to millions of people each year, and if we can do something to stop them, it's worth trying, right? And then again, we have several different resources to explore that in more depth. We have one on engineering the world around us, editing in the environment. That one explores 3 different case studies of different environmental issues to which scientists have thought of a genetic approach. One is editing the cassava plant to lower toxicity. Another is potentially editing mosquitoes to help save the Hawaiian honey creeper population, which is a really important bird in Hawaii. And the third case study is actually about the project working on de-extinction of the woolly mammoth as a potential approach to our warming climate, which is really fascinating. And students really get excited about the idea of bringing woolly mammoths back, right? But yeah, you can see the other lessons that are there: DNA, crime and law enforcement, genetics, jobs and rights, and then the lessons on eugenics, and a separate lesson that actually is all about using primary sources. So we've collected a bunch of historical documents from the time the eugenics movement was in full effect, and we have students look at those documents and kind of try to analyze what was being said, who produced it, who the audience was, and what their ultimate goal was by producing these things. And again, there are 3 units on social implications that are part of the PBS Learning Media resources for the film, and 3 little snapshots as well. All right, so this is just sort of a kickoff today for a series, right, of 3 meetings that we're going to have. And instead of presenting all the information, here live during the webinar, we're just going to let you explore those resources sort of on your own for the next week before we come back together a week from today. So what we're asking the educators to do in the next week who are participating with us, one would be to watch the Introduction to Personal Genetics video from the pgEd website, and you can see the link there. We're having you watch the lesson as it's presented on our pgEd website, just because that lesson, that intro lesson, covers the information that is in several of the PBS Learning Media resources. So it's a place where we can just kind of send you to one thing to kind of get all of the background information. And once you've watched this Introduction to Personal Genetics presentation, then go to the PBS Learning Media website and review the lessons that are in the section called Treatments and Access. And again, this will be a quicker review. Watch the video clips that are there, but a lot of the information is going to be familiar from the introduction lesson that you've already watched. So it should be just like looking over the resources, how it's structured, and that sort of thing, how you might be able to use it, think about how you might be able to use it with your students in your classes. And then the third thing that we would like to do is actually foster some discussion. So we've set up a workspace on Slack for the discussion to happen, because I think that's where a lot of the magic happens with these lessons and that sort of thing. It's the discussion that it fosters among people, because a lot of the topics that we talk about are, they're controversial. Not everyone agrees on them. And, there are really, really valid reasons for people to come to different determinations about how they feel about these different genetic technologies. So we're offering this space on Slack for participants to come together and have those conversations about those issues. All right, and then just a little information here about how to use Slack in case you're new to it. Slack is sort of like an instant messaging platform, but a lot of people use it, with their work group and that sort of thing. We've set up the space. The one that we're showing here is the example we had taken from an online class that we offered, but it's going to look very similar when you log in. On the left-hand side, you're going to see a list of channels. So the channels are basically like topics for discussion. So, like here we had one for introductions where people introduce themselves, a lounge just as like, chit chat kind of place and that kind of stuff. And then we'll have different ones we'll have a week 1 channel to discuss things this week, and then we'll have some channels for the topics next week. And then you can also send direct messages. So it'll list out the other people in this work group. If you have like a question specifically for me or Nadine or whatever, you can send direct messages there. When you're looking at Slack, up at the top, you'll see a channel header that'll just kind of explain what that channel is for. And then here's where you'll see messages and shared files. And when you're writing a message at the bottom, here are your typical buttons for formatting your messages. You can use the @ symbol to mention someone so that they'll get a notification that they've been mentioned. And then you can share files on there if you wish to, just like putting an attachment. You can react with emojis. You can start a thread, and we'll really encourage you to use this thread feature, because in the Slack channel, there'll be like a lot of messages that come up, people saying different things. And if you want to respond to a particular message, if you just start writing in the channel, it'll just show up at the very bottom, and it won't be connected to the message that you were actually trying to respond to. So if you want to respond to a particular message, click this button on the message, and that'll start a thread. And then you can see over here, this is that thread popped out, and you can see where Nadine and I responded back and forth to one another. All right, so it's pretty simple and straightforward. Play around with it for 10 minutes and you'll have it figured out. And then the last thing is, we always, before we start these conversations, as I said, a lot of them are controversial, push people out of their comfort zone and that sort of thing. So we like to set ground rules for interactions. And typically we set these ground rules as a conversation in a live event, but since, this way this is set up doesn't really offer that opportunity, we've just copied down some of the typical ground rules that we use for our conversations. So we ask people to listen to understand, not to respond. That your focus should be on learning and not debating. Assume positive intent, really realizing that intent can be different than impact. So, sometimes somebody will say something and it could be taken a couple of different ways. It could be taken in a very offensive way, or it could be taken in a way they're like, give them the benefit of the doubt that they weren't meaning to be hurtful by what they said. So we try to assume that people are not meaning to be hurtful, but also realize that even if you're the person who said the thing and you're not meaning to be hurtful, that it may have a hurtful impact on other people. So just own your words. Speak from your own experience, use I statements, speak only for yourself. Critique ideas, not people. Again, it's perfectly fine to have a different opinion on something, but just make sure, if you're going to disagree, that it's focused on the idea, not the person. You don't have to agree, but you must be civil. So be nice to one another. We talk about this a lot with our teachers in life, things like just the ability to have civil discourse, the ability to not agree with someone, but to treat them with humanity. Like that's a skill that we as a society need to practice more. And so if we can get these conversations going and have our students practice that, I think we'd all be better for it. And then it's okay to change your mind. A lot of times we see this happening live in the classes. Somebody will feel a certain way about a topic, and then somebody who feels differently about it will share their reason for feeling differently. And then the person's like, oh yeah, that makes a lot of sense. They change their mind. That's fine. There are no right or wrong answers to these things. And there's, often not a lot of black and white. There's a whole lot of gray in between, and you may find that that you change your mind, or that your opinion shifts a little bit on some of these things, and that is fine. All right, so I will end it there and say we will see you on Slack. Nadine and I will be available on the Slack channel to answer questions or respond and that sort of thing. But otherwise, I don't know if anybody put questions in the chat or anything.
There's no questions so far, but again, if anybody has a question, feel free to drop it in chat. I'll keep an eye on it. I will say in addition, so Rosemary has shared the link for you to sign up to Slack, so you can join us there. It's in the chat, but she will also send out an email to all participants soon, so you don't have to, if you don't have time now or you don't feel like signing up now, you'll get that link later on. And also the independent work that Robin shared, kind of like watch the video for this next week, it is in Slack as well. We have an announcements channel where that kind of is listed with the links. So again, don't panic that you didn't maybe copy that link. I don't know how you would copy the link because it's generally all these numbers and letters, but it's in our announcements channel. And in that same channel, I've also included kind of a guide to Slack. So if you're new to it, some of the tips that Robin gave are in that guide. So just for you to review and kind of get yourself familiarized. But I think that's it for what we had.
Yeah.
I think you're on mute, Rosemary.
All right. Well, thank you all. This has been really helpful. I do want to go over some housekeeping things as our other educators have. And we do have a few other special guests that are here with us now. And so thank you, Robin and Nadine, for sharing all that wonderful information. And I'm really excited to have a conversation over Slack, because it's been really great to set it up with you all, and you guys are really responsive. So thank you for all that you've done for this presentation today. I do have another special guest who I'll make a presenter in just a moment. We have Steve Hinckley as one of our guest speakers today. He is a president and CEO of Adventure Science Center. And we're so glad to have him here today to speak a little bit. And we are also excited because it's the 75th year of our Adventure Science Center that has been in the community of Nashville for over 75 years. It's so exciting, and remains one of our premier hands-on science and innovation centers in our city. And just before I hand it over to Steve in a moment, prior to moving to Nashville, Steve has served as the president of MOXIE in the Wolf Museum, an Exploration and Innovation Center in Santa Barbara, California. And before joining the Science Museum field, Steve Hinckley has also earned his degree in biology from Tufts University and has spent 10 years in the classroom teaching middle and high school biology, physics, and physiology. We're really glad to have him here today. I'm going to switch over here and invite him to speak. One moment. All right, Steve, are you with us? Unmute. Hello, Steve.
Hey there, can you hear me okay?
Yeah, do you have your camera on?
I do. I went to hit start video and it says the host has stopped it, so
Okay.
I'm not sure.
Whoa.
You
Try
know, we've
again.
been doing virtual meetings for several months and there's always a fun little quirk that pops up. And as we say as the Science and Technology Museum here in town, that of course is technology that never works for us.
That's right.
Almost
Try again, Steve. We should have you up and running.
there we go.
Awesome. Welcome. So thank you for being here. I wanted to invite you to be here to also start the conversation around about your experience in teaching genetics in the classroom and how you can share a bit about how you taught the subject both in the classroom and what you're doing in the museum.
Sure. Yeah, absolutely. Well, thank you for having me. And it's also great to listen to the presentation. It was really good to hear what you all are sharing, Robin and Nadine. It's very, very cool. And as a Tufts alumni, my heart is a little bit in Boston with you all. And I'm trying to endure a season of watching the Red Sox without fans nearby. But hope y'all are doing well. And great presentation. That was a lot of fun to listen to and very, very cool the work that y'all are doing to support this film. So as Rosemary mentioned, I did teach biology and genetics obviously was a big part of what I was teaching when I taught 7th and 8th grade, and then also again as I taught 10th through 12th grades. So middle school and high school was primarily my focus there. And I will say of all of the subjects that I taught around biology and anatomy and physiology, genetics to me was one of the best topics to teach. And part of the reason why I loved it so much was because it was so deeply engaging for the students. You know, when you're talking about middle school students and high school students, particularly 12th graders, sometimes it can be hard to retain that attention span a little bit. But genetics is one of those fundamentally fascinating topics. I mean, in the Science Museum world right now, we say that there are certain things that you can never get wrong. You can never get dinosaurs wrong. You can never get space travel wrong. And genetics is another one of those topics that you can never miss with. It's ultimately fascinating. It certainly can be a very complex and intricate idea to convey, particularly to middle school students who are just starting to really understand very complex ideas. But it was one of those topics that even though it can sometimes be intimidating, I had the deepest engagement from my students learning genetics because ultimately it was entirely compelling because it was about them. And whether it's the teaching and learning that happens in the classroom or the teaching and learning that happens in an informal setting like a science museum, there's almost an automatic win for any topic that helps people learn about themselves. They're fundamentally curious about who they are and want to understand a little bit more about themselves, their families, and the people around them. So again, genetics hits that target right on. As I used to say to my students, one of the very first things I would share with them walking in my door at the beginning of the year is that your body is the only thing you'll ever truly own, and you need to understand it. You know, there are a lot of things that we try to understand about the world around us. It's the world inside of us that really is a great place to start. So again, it was just laying that foundation for really diving into genetics. When I was teaching, some of the things that I found incredibly important around genetics were trying to come up with as many hands-on elements of that instruction as I possibly could. It was just such an easy way to bring the content to life. It was also very good to help illustrate, again, concepts that can be very complex and very challenging to understand just through communicating verbally or even visually. So hands-on was absolutely critical for us. Whether you're talking about laws of segregation and independent assortment, or you're starting to get into Punnett square running, one of the best activities that I found, and I was actually surprised by the level of complexity complexity that my 8th grade students were able to handle was Drosophila melanogaster experiment, you know, doing the typical crosses and Punnett squares for fruit flies. And we would run that experiment for about a month. And so you'd get a couple of generations of fruit flies, so you could really start to see how genetics played out in the real world versus just having certainly a lot of the hypothetical conversation through graphs and whatnot. It was about bringing it to life, and I was very impressed with how students managed populations of fruit flies over the course of several weeks. And keep in mind, these are 13 and 14-year-old kids, but the level of engagement that they had and the level of complexity that they were willing to challenge themselves to understand because it was genetics was really quite extraordinary. So again, it's hard to underscore what a compelling topic it can be for kids and honestly adults. It really is a lifelong topic. I also found that context was absolutely essential. You know, certainly we wanted to make the connections between genetics as sort of a micro topic and really the broader context of evolution, and then even beyond that into larger systems thinking, wanting to correlate it to you know, evolution and climate change. You know, how are organisms adapting to a continually changing environment, and starting to explore some of those things as long-term, bigger picture ideas. Harder to see play out in real time, but certainly important things that connect the idea of genetics into much larger ideas that, of course, is hugely important. You know, today, I'm obviously not in the classroom, but part of the things that we can communicate when we interact with school students through the Science Center. But if I were to be back in the classroom, you know, you might even look at COVID. And think about how certainly there's the genetics of viruses and the evolution of those things, but you also have human genetics that come into play in terms of people who are more or less susceptible to COVID. There was a very interesting story. I don't know if you all listened to Radio Lab, but there was a fascinating Radio Lab episode done on a study out of Boston that researched the frequency and the prevalence of COVID in the homeless population. And I won't spoil the entire story for you, but the long and short of it was that there seems to be some type of correlation, which is different from causality, but there seems to be some type of correlation between people who spend more time outdoors building up vitamin D, which then has almost an immunosuppressant effect on part of the immune system that would otherwise create some issues for people. So it's really quite fascinating how genetics plays out in contemporary stories. Now that I'm in the Science Museum setting and have been there for a number of years, the kinds of things that we do, we'll take educators that we have on staff out into schools. We do a lot of programming, particularly around biotechnology. Genetics is certainly one of those areas that we talk about. And we'll head out to schools. We bring the kits of supplies with us, so the teachers really just have to make the call and make sure that we show up in the right time where they're addressing genetics and biotechnology in their curriculum. So that's a really impactful way that science museums help support the learning that takes place in the classroom. We also do a lot of professional development programs, particularly again around biotechnology and genetics, as well as a number of different scientific topics, but those are some of the ones that we do to impact. We've got activities online that families can do from home, particularly relevant during the time of COVID, where everyone's been somewhat sequestered and quarantined at home. But even beyond COVID, there will always be rainy Saturdays in Nashville and everywhere else. And so having DIY activities that folks can do from home, like strawberry DNA extraction, are some really critical and helpful hands-on ways to start to understand the topics like genetics. And then because we're a science museum and a lot of what we like to do is fun and events are just really cool, fun things to do, we celebrate DNA Day. So every April, we celebrate the Human Genome Project as well as the discovery of the double helix in April of 1953, or the announcement of that discovery. It was really more like it. So we're always celebrating, we're looking for any excuse for a party. And then with those, we also look for volunteers and community partners from the schools, the research institutions, to come in and help us communicate more about genetics and DNA to our public. One of the resources that we've really relied on here that if you're not familiar with, that I would highly recommend checking out. In addition to all of the great content that was shared during the presentation, I would highly recommend looking into Hudson Alpha. If you're unfamiliar with it, it's a short drive down the road, just down I-65 from us in Huntsville, Alabama, and it's part biotechnology research cluster, but then there's an entire educational element that has been developed as a part of that. They do a ton of professional development. They do professional development camps in the summertime, and then they also do a lot of resources that are available online. You can actually arrange to have field trips down at their space and interact with top flight biotechnology equipment. It's an extraordinary resource for teachers and students, and it's certainly one of the partners that we've relied on to help develop some of the curriculum that we deliver to school groups as well. So I would highly recommend that. They've got great kits of materials, which particularly right now can be very, very helpful, since a lot of the in-person interaction with schools isn't happening. Those kits can really be lifesavers for educators looking for hands-on activities. So I would give a huge shout out to Hudson Alpha just down the road from us. So that's a little bit of my personal history and the way that I've approached teaching genetics, but then also how the Science Center, as well as our partners, really help to communicate that content to a larger audience. So Rosemary, I'll send it back over to you, but thank you again for having me on today, and it was great to be listening in on the presentation, so thank you.
Glad to have you, Steve, and to have all your resources that you bring to our community to accentuate what we're going to learn over the next few weeks. So we're glad to have you. I do want to introduce some more of our team teacher leaders that we have, and just give me a moment here as I switch screen. All right. So let's see. My apologies. So we have some really great educators with us here in the Nashville and Metro Nashville Public Schools with the STEAM program. We have added arts to the STEM program in our city, and we're very proud to include everyone in the conversation with science, technology, engineering, arts, and math. And we have some key teacher leaders from the Metro Nashville Public School STEAM Initiative. And before I introduce them, I just really want to briefly thank Tiffany Griffin-Miner and Jennifer Berry for all your help in facilitating this partnership over the next few weeks. Over the course series, these teacher leaders will be also in the Slack chat and connecting in conversations over each of the events as well. And on the last day, they will be hosting breakout rooms to encourage conversation, networking, as well as making sure that we're all comfortable with the norms that Robin has set earlier. So our STEAM teacher leaders with us during this series are Carrie Arias, Rebecca Hunter, and Thomas Francis, and Heather Barker. Let's welcome them, and I'm going to also invite them to have a few words and just introduce themselves briefly, as well as share a little bit about what you're doing in the classroom. I see Rebecca here. If you, I'm just going to allow you to speak. Yep. And I see Tiffany here. Do we have some other ones? If some of these, yes, Tiffany, do you have your hand raised? Tiffany, you're talking. You can talk. Did you have a question?
This is Thomas Francis, just letting you know that I'm here as well.
Oh, Thomas, great. I'll change your name.
Okay.
I'm here, but I wasn't speaking. I'm sorry.
No worries, no worries. So thank you all for being here today with us and throughout the series. I just want to have you guys introduce yourselves and share a little bit about where you teach, what age, and how you're teaching genetics in your classroom. Rebecca, would you like to go first?
Hi, sure. Thank you, Rosemary. I'm Rebecca Hunter, and I teach 5th through 8th grade STEAM at Jerry Baxter in Nashville. How I plan to incorporate genetics into my classroom is definitely from the historical standpoint. In a STEAM classroom, I have a lot of freedom to integrate different things that I want to teach, and I plan on teaching the historical aspect and tying that into like current social justice. And looping in the PBS resources and clips from parts 1 and 2 of the documentary film.
And Tiffany, are you one of the other guests here?
Yes, I'm here. Thank you very much for this opportunity. And thank you so much for the leadership you've provided throughout, like having the opportunity to have these conversations. It's been really interesting to have an opportunity to listen to the material that Robin presented to us earlier this week. And then also just having so many resources at our disposal that we can explore and better understand the topics has been extremely helpful. So thank you very much.
Yeah, you're very welcome. And Thomas, do you want to add anything about where you teach and how you incorporate genetics into your curriculum?
Sure. Again, thank you for the opportunity. My name is Thomas Francis, and I teach at Moses McKissick Middle School. And I'm a 5th through 8th STEAM teacher. And so I have not taught genetics, but that's one of the reasons why this opportunity was so important for me, because I do plan on reviewing all the resources that you have, the videos, and to see how I can best incorporate the gene into my classroom. Because right now we're learning about COVID-19, and so we're dealing with viruses and bacteria, pandemic, epidemic. And so that's what we're currently learning. And so now I can see how I can incorporate or integrate genetics into what I'm teaching now.
Right. And we also have Heather Barker with us. Heather, would you like to tell us about what you teach and how you teach genetics in your classroom?
Sure. Yeah, I'm Dr. Heather Barker, and I'm teaching STEAM also at the 5th through 8th grade level. This year, it's I'm new to the district and to the school and to teaching STEAM actually, so it's been really exciting. Currently, I'm kind of teaching some stuff about the pandemic, similar to Thomas, I believe. I'm thinking about ways to incorporate more genetic stuff into that. Because all of these resources are so valuable. I've taught high school level biology and undergraduate level biology, and thinking back on those experiences, I wish I'd had access to these materials at that time for sure. So I appreciate this opportunity, and I'm excited to see how I can incorporate it into what I'm doing right now.
That's wonderful. And I believe the last one is Carrie Arias. I'm going to unmute you or unmute yourself.
Awesome. Hello, I'm Carrie Arias. I am a 6th grade science teacher at Antioch Middle School here on the southeast side of town. And it's interesting that I don't actually teach human genetics at all. It's not part of the 6th grade curriculum, but we do talk about adaptations for survival and how species have adapted over time to their environment. And so it'll be really interesting to be able to tie in some of these ideas about, the similarities between the human genome and the other various species, and then also how humans themselves have adapted over time to be able to fit in with whatever environment they are living in at the time. So really happy to be here and honored to be a part of this. And I also wanted to throw in that I was that one person who's done my my ancestry DNA. So
That's great. That's great. I've also done it myself. It's quite interesting. Well, wonderful. I do have a few other things to just kind of reiterate before we leave. I wanted to share with everyone. So let me switch over. So we do have a survey. I will share the link in the chat here briefly. But if you are privy to QR codes, you can simply take a picture of this QR code and have it and take the survey now on your mobile device. I will also email this survey about how this first event went, and we'll be doing these after each and every event. So please, I encourage you to take the survey and tell us what you think, and tell us what you thought went well and what can be improved. We can always improve ourselves. Finally, I wanted to remind everyone to sign up on the PBS Learning Media. It is a free resource to you, and you will be able to see the gene and intimate history, and as well as all the resources that go with it that Robin and Nadine shared. Also, if you're an NPT member, you can also access the full series on our website through the Passport program. And we'd also like to thank our sponsors that are connected to the gene and the intimate history of the film, all these wonderful sponsors who made the film possible. And then finally, thanks to WIDA for providing this grant to make the program possible, as well as to our educational partners for pgEd and STEAM, Metro Nashville Public Schools STEAM Initiative.